This video is designed to help remind you what the y equals mx plus b or slope-intercept format does, tell you about an equation of a line, and also how to find that equation of a line given 2 points. So here are 3 examples of lines in the slope-intercept form. That means that each of these lines is given in the format of y equals mx plus b, which we see over here to the right, and m, the coefficient of x, is the slope of the line, and b, the last term there after the plus sign, is going to be the y-intercept, or where it intersects the y-axis. So you'll notice these 3, I've written the 3 equations for the 3 lines, color-coded. So the green line is y equals 2x plus 5, and that shows right here, this line right here, it's y equals 2x plus 5, and conveniently, it intersects the y-axis at 0, 5, right there at this point. So that's fairly obvious if you plug in x's and y's for the input-output table. If you plug in, let's say, where does it cross the y? Okay, doesn't really matter. If you plug in 0 for x into y equals 2x plus 5, you're going to get 2 times 0. So you're going to get 2 times 0 plus 5. So obviously you get 5. So this slope-intercept form is extremely useful because you can just look at the equation and know where it's going to intersect the y-axis. So once again, as a reminder, this one is intersecting the y-axis right there at the on the intercept there at that point. Equivalently, y equals 2x plus 3 is going to intersect the y-axis right there at that point at 0, 3, and y equals 2x plus 0 is of course going to intersect the y-axis at the origin. What this is telling us, again, this point right here, 0, 5, this point right here is 0, 3, and this point right here, of course, is 0, 0, and those are all the 3 y-intercepts. So, if we're looking at a line and we've found the slope, and let's say the slope was 2, how do we know which of these equations it is? Well, we can graph it and see approximately where it crosses the y-axis, but we can also calculate that b, because each one of those lines is a representation of all the points that satisfy the equation. So if the equation is y equals 2x plus something, and we plug in a point that is a point for sure on our line, then we can actually calculate the b that works to make that our line. So let's take a look at how that works on the next slide. Suppose we have these 2 points, and we know that we want the equation of the line that goes through them. So the first thing that's useful to do is find the slope. So we're going to figure out what the change in y is, and so the change in y goes from 5 to 2, so the change in y is -3, we go down 3, and then we figure out what the change in x is. The change in x goes from -3 up to -1, so that's a change of +2. What that means is our change in y over change in x, which is of course the definition of the slope, is -3 over 2. You could also write this as -1.5, okay, -1.5. So that means we can write the equation y equals -1.5 plus something. We'll call that b. And what we need to do, 1.5x, excuse me, plus b. Now our goal is to solve for what b is, so that if we plug in -3 for x and 5 for y, that will work. And if we plug in -1 for x and 2 for y, that will also work. So let's start by plugging in one of those points. Let's plug in -3, 5. So we'll plug in 5 for y equals -1.5 times -3 plus b, and we'll simply solve for b. So 5 equals, and -3 times -1.5 is positive 4.5 plus b, and therefore b must be 0.5. It'll be a half. So we can double check if that works by using the equation y equals -1.5x plus 0.5. We think this is the equation now. Let's double check that -1, 2 is indeed a solution to this equation. So let's plug in 2 for y equals -1.5 times -1 plus 0.5. Now -1.5 times -1 is 1.5. So 1.5 plus 0.5 does in fact equal 2, and therefore we have found that this -1, 2 is also a solution for this equation. That means we've found the equation that has the slope of -1.5 and goes through both these 2 points. So we've completely satisfied it. This process works every time. Once you've found the slope, you simply plug in one of the points into the equation using the slope replaced with the value that you found, and solve for b. It's useful to double check with the other point, and it's also useful to often make a quick sketch to see if it looks like it's about right, because if you got a sign switched somewhere, something could be going on, or if you did your plugging back in incorrectly. So let's check that on the next page. So here we have just a xy coordinate axes to plot these points. So the points we had were -3, 5, so over 3 to the left and up 5, 3, 4, 5. So there's the point -3, 5, and -1, 2. So there's -1, 2. And if we draw a straight line through these guys, we should be able to come up with the following. Let me try to adjust that. Sorry about that. So let's adjust it and tilt it. See if I can. And there we have a line that goes through there. And as you can see, that approximately goes through 0,5 right there, 0.5 right about there. So we've established that approximately that point is approximately 0,0.5 based on our graph, and of course we've calculated that it's exactly that point. On the final slide we'll do one more example. So here we have another couple of points, and we'll calculate the equation of the line that goes through these 2 points. So first let's get the slope, and that means we're going to find the change in y, and so the change in y is going to be +2 as we go from 0 to 2, and the change in x is going to be +4 as we go from -2 to 2. So the change in y over the change in x is 2 over 4, or 1/2. That means the equation for our line is y equals 1/2 x plus something, which we'll call b again, by convention. So let's plug in the point 2, 2. So we'll put in 2 for y equals 1/2 times 2 for x plus b. Of course, 1/2 of 2 is 1, so 1 plus b equals 2, which of course implies that b is 1. So we'll double check that our equation y equals 1/2 x plus 1 is in fact what we're looking for by plugging in the other point just to double check. So we put in 0 for y equals 1/2 of negative 2 plus 1. Of course, 1/2 of negative 2 is negative 1, and negative 1 plus 1 is, of course, 0. That gives us a correct answer, and therefore this is the equation of the line that goes through these 2 points. Sometimes the numbers are a little messier, but this was a nice clean one, even though we have a fractional slope. And we can calculate b quite easily, and in this case we got a whole number. I hope this helps.